Hey, welcome back to Math with Patrick and Quill. Today is November 27th, and we're solving problem 331 from the Daily Epsilon calendar. And we should show why the answer today is 27, because that's today's date. So let's find the maximum postage value that cannot be made with 5-cent and 8-cent stamps. So this suggests to me, just kind of like knowing the answer is 27 for a sec, that 28 and all numbers greater than 28 are possible. And then we're probably going to have a few possible numbers below 27 as well. Like, of course, 8, 16, 24 will be possible just by collecting up 8-cent stamps. All multiples of 5 are going to be possible as well. But then combining these together, we could get like 13 as well. So there's a lot of options below 27 that will work, but there should also be other options below 27 that won't. It's just that 27 is the largest number that we cannot make. At least that's what the problem is suggesting. So let's try to figure out why that's the case. Let's do the easy part, right? So we could, not send a letter. We could have 0 cents by not picking any stamps. And then if we just pick 5-cent stamps, well, this will help us create any multiple of 5 that we want. And so I'll just count up these, multiples of 5 up until I hit, let's say 40. I feel like 40 is a good number just because it's like 5 times 8. And so if I only use 8-cent stamps, then I can get all my multiples of 8. I'll try to intersperse it so I kind of have a number line going here. And there we go. Okay. So all of these numbers are totally doable. And right now I actually want to prove why 40 is a good stopping point. So here in this first list, we can tell that we'll hit all multiples of 5 starting with 40. But then my idea here is I want to be able to create, say, like a 41, a 42, a 43, and then a 44. Because then we can just show that we can add 5 to all of these ones. And effectively, we're just playing leapfrog up through all the numbers 40 and greater. So here, we already know that starting with 40, we can reach up to 45, and all multiples of 5 after that are covered. Starting with 8, we could count by our tens just to be a little bit more quick here. And then once we get to 38, now let's count by our 5s. That will help us hit 43, and then all plus 5s after that. Starting with 16, I know that we could jump to 36, and that would jump to 41, so that's covered. Starting with 24, we could jump to 34, then 39, then 44, so that number is covered. And then starting with 32, that could be 42, 47, and then, just 42. Duh. And then that covers that one. So stopping at 40 is totally sound because there's pretty easy strategies to get all of these numbers. And then we can just kind of see from here on forth, 40 and higher is totally covered. And it just kind of comes from starting at any one of these numbers and then counting up by 5s. So it is reasonable to stop looking at 40 because there's a fairly easy proof why numbers greater than 40 don't work. And then also seeing that we have the number 40, it's pretty clear that numbers greater than 39 don't work. And now I guess all we really need to do is try to figure out all the different ways to combine 5-cent and 8-cent stamps, stopping at the number 40. So I guess I could have 0 through 8 5s, and then 0 through 5 8s. And then here is just going to be an array that tells me all the possible stamp combinations that go up to 40 cents, but then also more, right? Because this 0 8s and 8 5s scenario gives me the value 40, as does this. And so we're probably going to see that all of these values kind of in the bottom right of the array add up to more than 40, and we don't really need to think about them. So let me actually fill in this row and this column because we already have that on the page. Cool, so here's the obvious row and column filled out. I want to cross these out in red just because these numbers are going to be greater than 40, and we've already proven that we can always get a number greater than 40. And then let's just count by our 5s again, right? So this is 13, this is 18. I think counting by my 10s is a little bit easier. So basically, I'm just employing the same strategy as before to fill out more values in this table. And I know that adding another 5 is going to be too big there. Let's add by 10s again. So 13, 23, 33. We'll get 16, 21. Again, adding by 10s just because that's easier for me. Oh, cool. And then the next one would be 41. That's too big. Let's fill in that last value there and cross out anything else because we don't need to think about numbers 40 or more. Counting by 5 isn't that hard, so I'm just reverting back to a different strategy. 29, 34, 39, and then getting rid of all of these. And then this seems to just be kind of quick because we're basically showing all of the possible values, I think. Let's see, 32, 37, and then, yep, that's it. So I believe this is our total sample space. Maybe what we can do now is start with 40 as like the number that we obviously have, and then just count down until we can't find a certain number. So we have 40. We have 39, 38, 37, 36, 35, 34. This is kind of nice. It's like I can kind of keep scribbling out diagonally this way. So I do have some kind of methodical strategy to help me visualize my counting here. 33, 32, 31, 30, 29, 28, and where is 27, right? 27 should land somewhere here-ish. But as you can see, we have 25, 20, 23, 26, 21, and 24. No 27. So since 27 is missing, this is the largest value that we cannot find by using 5-cent and 8-cent stamps. So there is my solution. I think we're all done. Hope you enjoyed. I'll see you tomorrow. Bye.